And I think we are live. Okay, and we are. Okay, so hello everybody. It is now currently 20:25. It's a little bit late, sorry about that. But it is now the Q&A&Critique number 75, the Let's Bforartists edition. I'm here with a couple of good friends of mine and a new special guest who we may hear about in the future, which I'm very excited about. And we're here to talk about what's new with Bforartists 3.4.1, which is not a lot, but it is a bug fix update. Also, we're going to take a quick look at the basics of geometry nodes to lose our fear of how to use it. If you're a beginner, if you know how to do things, then it's going to be super easy, and you can probably skip this chapter. But with that, we'll just go through some basic procedural modeling to create a quick and easy table. And next after that, we're going to take a look at some art that we have seen here in the server, or art that has been submitted. So far, the only pieces we have available at the moment is pending. So without further ado, let's begin, and let's talk about what's new in Bforartists 3.4.1. If you're new here, you may have known me to... No, if you're not new here, you know me for working with Bforartists, which is a fork of Blender focused on user interface. If you're new here, and you're watching this for the first time, well, Bforartists is basically a whole bunch of icons added to Blender with a whole bunch of like little interface tweaks to make things a little bit easier, a little bit more consistent, and quick to discover things. So operators that are hotkey exclusive are now added to the interface, and other options that you could ever want, for example, overlays to change the wireframe on and off without pressing a hotkey, you can just add it to the top header. And if you need to add a whole bunch of cubes over and over again, you can just click the toolbar at the top and you can customize it to whatever you need. And if you're working with geometry nodes and you don't want to have another window for shaders, you can just quickly switch over to shaders or back to geometry nodes or shaders again with a single click. So Bforartists is something that we've been working for many years now, and we currently just released the version 3.4.1. So with that, there's been a couple of things new, and this means that there's been an update that you can download now, which is also available for Linux and Mac. So what's basically new is that the asset library, or the asset browser catalog category, has got some new features from Blender, and we added the icons, so you can access the asset library path, add a new catalog, save the asset catalog, or do it directly from here as well. So these two buttons are just added to the catalog category here, along with the default menu, which I'm now working with a couple others to create a default library for geometry nodes and other nodes. Hopefully later this year we will complete a very good default library for you, but that's a work in progress. Another thing is that when you create a camera from the toolbar, the orientation is correct. Before it used to be pointing downwards, but now it's pointing to the side as it should. And we also fixed a number of bugs and another features for stability from Blender. 3.4.0 had a number of issues and was highly unstable. Blender released another version and it fixed all those issues. And we also have a couple of new add-ons, a couple new nodes inside of Bforartists. So that's good. So I wanted to ask you, so if you're here connected, let me just double check on Twitch. Have you worked with geometry nodes before? This is my question for you today. We're going to see if we can find some answers, and we're going to go through making this procedural table. So if you have made, or if you have worked with geometry nodes, blink twice. Or write into the chat and let me know, or if you want to, you can open up your microphone. And if so, how was your experience? Have you worked with geometry nodes? And if you have, how was your experience? think one of you have done it before, Plebes, right? We've talked with you before with geometry nodes. Oh,
Yeah, I've did geometry nodes. Kind of since the beginning, didn't do much with the old workflow before 3.0, but since 3.0, I'm pretty active with it. And it's been amazing, kind of. At the beginning, it was very experimental, but I think at the current state we are now, gets better and better. And
that's right.
I'm updating one of my geometry nodes assets now, and there's a lot I can enhance about it just from the latest improvements to geometry nodes. Like we have a lerp node, and we can have instance colors and attributes.
And it's a lot more interesting now, that's right. And also, like, the whole flow of data with fields and the connections of fields is a lot more interesting. Darkfall has mentioned that he's worked with geometry nodes before, and your mind was blown. Great. It was difficult to understand at first, since your math sucks. Makes sense.
Learning shaders or shader nodes maybe help the process of learning geometry nodes?
Yeah, definitely. So there are some nodes which are almost identical to compositor and shader nodes. And dark folders started before they were fields. So I guess you understand the concept of named attributes quite well. Okay. Well, that's good to know. There's been, with geometry nodes, I'm still learning it myself, to be honest. Oh, when they implemented fields, you got a little bit confused. I understand. I think when it comes to geometry nodes, you have... Let me just hide the lights. There we go. When it comes to geometry nodes and fields, to me, it helped me understand that a field is basically... A value is like this one cube. This cube is a value. If we have like a name over it, the basics ideas is that helped me this week, that really helped me understood, was that a cube could be a value, or no, and well, this is a representative. So if I'm here and I have a value, this could be a float, or a float, it could be a type, a value of some kind. It's a type, kind of like a float or a string or an integer. These are like different types of things, different types of values. And this is just one of them. But when I think about a field is basically a whole bunch of them. So if I use the array modifier, this is where we understand how fields are like arrays. So when you have multiple values and floats, or multiple vectors. Vector is another important one that we have. So a field is basically an array of data. And how we define where this array of data is basically in the domain. Hello, Lich. So in this case, a domain, we have 4 domains inside of Bforartists and Blender and Bforartists. The first domain is basically an object domain or a mesh domain, a geometry domain. Then we have the curve domain. And then we also have the point cloud domain, which, let me just take a look. Here we go, point cloud. So in this case, I can't create a point cloud at the moment because I need an object to do that. And I also have the instance domain. So if I have, for example, this shader ball, I can instance it as a collection. And here is the shader ball. Where is it? There it is. Just make sure that I can see it. There we go. So here's the shader ball. I can move it over here. Why can't I move it? Why can't I move this? Oh, that's this. The light. Shadable instance. Why can't I see the... Strange. Wonder why. Okay, so basically an instance is a scene collection that has been changed into an instance, and with geometry nodes we have those 4 domains: the object domain, the curve domain, the instance domain, and a point cloud domain. Point clouds are good for your VDBs for later, but I don't know much that you can do with it for now. And hello Liz, for connecting. So in this case, since we have a domain, each domain could be created from a number of different types of fields. So for example, if I'm in this cube has a face, has edges, has these corners, and with that we have what we call an array, a field within that domain. So this point field, is basically an array of points on the domain on this object. So all of these points inside of the actual array are what you would call a field. Same with all these faces. All these faces here is an array of faces in an index. So we have face 1. We go inside the index settings. We can show the indices. Indices, really? Wireframe, face orientation, statistics, face angle, normals, edge, mesh analysis, vertex groups. Oh, I wish I remembered how to turn on the indices. That was something I wanted to learn, but I haven't found it yet. Measurements, face area, face angle, mesh analysis, overhang, intersection, shot type. Whoops. I will probably have to 08's hidden wireframe, pivot centers, mesh motion tracking, fader and active geometry, origins, path, objects, statistics, edge marks, normals. Ah, cool. Well, we got a lot of data, but I don't know where to get the indice. Looks like it's not built in yet. Wireframe, face orientation, fade and active, motion tracking. Oh well. As you can see, this panel here, the viewport overlays panel, is slightly different than the one in Blender. It's probably a little bit, it's got labels, and we hide sliders when they're not needed, so that it becomes a bit more intuitive to see what you want to see, and not overwhelm you with everything. So with that, let's carry on. So now that we understand that a field is a group of values, and a field is from a particular domain, which is the object type. So you have different types of fields for different types of domains. So geometry nodes basically accesses each of these points. And as we can see, oh yeah, there is a number on each point. Really? Indices. Perfect. So we have point number 1 here. And why is it so small? Can we make it bigger? Alright, doesn't matter. So there's a tiny, you can do that. Would that be in the theme settings, I assume? Liz, I have a question for you. How do you change the indices buttons? In the settings preferences somewhere. So themes, 3D viewport, I assume is at the bottom. Increase pencil vertex size, no. Outline width, no. You're gonna check yourself, good. Hopefully we can find it. That's a good question to ask today. So tooltip, menu item, scroll bar, progress list item. Font size, regular. Toolbar item, ready buttons, text options, toggle number field. Value slider box, menu, by menu, pull down, menu back. Icon colors, axis and gizmo colors. Styles. I wish there was a search in the theme settings. That would be so nice. I will increase the font size. There we go. Nice and big. Or in the viewport settings. Nope. Doesn't work as intended, but that's okay. We'll just work with this. So you can select this point and it says 1. This point says 3, this point says 7, this point says 5. If I select a face, if I turn off the angles, I don't want the angles. I just want faces. Ah, it's still showing it. Oh, here it is. Edge length, angle, face angle, edge length. So there you go. So each face has a number. 1, 2. If I select them all, you can see that each face has a number. If I select all the vertices, each vertice has a number. If I select all the edges have a number. And this is really useful because now we know that everything is an array. So points, edges, and faces are all part of the domain. The domain is this object, same with this curve. If I select the curve, at the moment I can't see any of these values because it doesn't work yet. But each point has its own indice, each spline would have an indice, and all of these things. So can I change the order of the indices of a mesh? I think in geometry nodes you can reshuffle and change the order of indices. And reassign them dynamically. I'm still learning how, but you would be able to later. So that's the beginning. So basically we understand that a mesh is created out of points, vertices, edges, and a bunch of other details. If we go inside the nodes and make a new node tree, when we take a look at this, we can see inside this, the edge here that a mesh domain has vertices, edges, faces, and face corners. And a curve has control points and a spline. Point cloud has a point, obviously. And volume grids, oh, that's new. And instances. So with that, let's start making a table. So if you're inside Blender, you would have to use the Shift-A menu, which is perfectly fine. What we did with Bforartists is we added icons to all of these. Coming to 3.5, when it's released, this whole entire menu is going to be changed. They have decided to split it up into smaller groups with subgroups, which means in Bforartists we're also going to be changing it into separate tabs with subpanels and their menus. So you have the option of pressing Shift-A to add your nodes, or drag off and search for your node, or searching for your node directly. So if you look at the search menu, I usually assign it to Alt space or whatever you want. You can use the Node Tabber add-on, which is really good, similar to Houdini, where you just press Tab, search. Or you can use the side panel here from Bforartists, which we added with either in icon mode, so you have an icon for every single node if you learn them, or you can just have them with a name. So what we're going to do is we're going to create some mesh parameters. We need a cube and we need a grid. So what we're going to do is we're going to use this cube here and we're going to change this cube into legs. Hey Yush, long time no see, I'm glad you're here.
Hey Dries, how are you?
Very good. How have you been?
I've been well. Glad to be here.
Excellent. We're just I'm just giving a quick crash course of like how to make a procedural table with geometry nodes. So for those of you who are coming in later. So we're going to use this cube as legs, and we're going to use this grid as the table base, and then we're going to work with some extrusions, some instancing on points, and a number of other things like that. So if we take a look, if you have the node wrangler activated, you can hit down Control Shift and click, and this will add a viewer. So we can see in the viewport that we have this viewer. We can have a grid. There we go. So here's the grid with 2 vertices wide, and here is the cube. So what we're going to do is we're going to create some value nodes. So this value node here, I'm going to call this the height of the table. So I'm going to put 1.2 meters. And on the side here, on the value of the size, I'm going to add the size x, which would be the width. And I'm going to make another one here. I'm going to call this size wide, which is the length of the table. So let's say, for example, it's 3 meters wide, 2 meters wide, 3 meters long. And I'm going to use a combine node. Combine XYZ. The reason why is that I want to control the grid, which is the table part of the width and the size. As you can see, you have a value of size X and size Y. So I just plug in the X and I plug in the Y. And I'm good to go. And with the legs, well, I also want the legs to have a height of in the Z value, and a width of the legs going to be about 20 centimeters. Oh, thanks, Liz. I'll download that soon. Liz just shared a file in the Discord chat for an index viewer for fields, the second version. Excellent. So Liz is one of the characters one of the people that I'm starting to work with about the new default library for Bforartists. And I'm also been doing a deep study. Hopefully within the next year or so we'll have good documentation, examples, and a very good default library for you. But it's going to take some time. I'll get onto it probably later into February. You hope that too. I'm glad, Liz. I'm glad I can do this with you. Let's make something awesome. And with that, so now we have a cube, and now we have some legs. If we go and take a look, here's the leg space. The leg movement. Let's just isolate it so we can see it. So here's the leg right there in the 3D view. And we have the height of it. And then we have this grid. And we're good. So what we're going to do is we're going to use a transform geometry node. So the transform geometry node basically tells us, that gives us the ability to do translation, rotation, and scale. And this means we can use the height or this combine Z. We're going to do this again. And we're going to put the height onto the Z and move this into the translation of this table so that we have the height of this transform. So this is useful for like rotation or whatever that we want on the table. So for example, if we want a hexagon table and we want to rotate the hexagon of the shape of the table, we can use a hexagon geometry instead of a grid, or a circular radial geometry, or any type of thing. A star, we can make a star table if we want. But right now we just want a square table with the ability to change the number of legs. So now we have this, this grid and this cube. So what do we do from there? As you can see, some good things you need to keep in mind is that what I mentioned earlier, the values of a single cube that we saw earlier, the single value type, float, string, integer, etc. All of those are examples of a single value. If we look in the geometry nodes, these round circles that we see here, this means they are a single value. So for example, this value here of the length is just one number, one float, which is 3.000. That's one float. And if we take a look at this diamond shape that says UV map, a UV map has X, Y coordinates, which means you have a number of points which has a value pointing a certain array with an X and Y, and this UV map becomes an array of data, an array of floats. And in this case, this becomes a diamond, and this is a field. This means it says it's an array now. So all the diamonds are arrays, and all the circles are singular values. And you might notice that you can have a diamond with a dot, which means, I think one means the array has the same value, and the other one means the array, all of the items in the array has a different value. I think this is correct. Well, I'm not sure. So what we're going to do from there is nothing simple, is we're going to join them together now with join geometry. There is a shortcut to do this, which is hold down Control Shift and drag. Whoops, sorry. Right click. Control Shift right click, and it creates this green bar and you can connect these two with the join geometry node. And then from there, we can have these two objects together. So here we have a single-legged table with an infinitely thin piece of paper for the board. So that's not going to work. So what we're going to do is we're going to use the next most important thing that you need to learn with geometry nodes, which is scattering instancing on points. So the instance on points node is what we're going to use to drive the legs. So if I import this transform geometry into the points, this is going to be my parent. And let me just plug it in here so you can see it. And if I use a join node between these two, so we can see them both, just do some organization. So here we have the instance on points, but it's instancing currently the option of nothing, no instances. So we're going to use the cube, the leg, and we're going to instance it on each one of these points. So if I change the scale of this grid, I can have 3 legs at one end, or 3 legs in the center, or 4 legs. I can have as many legs as I want, or even in the center. But that's okay for now. So we have those 4 legs, and we're good. So the instance on points basically says, take an instance, use the points of the geometry. So in other words, use the points field, which is here. We have 4 points, 1, 2, 3, 4. Starts at 0. We have the position of all those points. So make an instance at each of those positions. So we have these cubes, each of the positions of this field, based on the index of 0 to 3. And we can choose instances from collections or whatever. And as you can see, we have this index here that says this green integer. It says we can choose, if we turn this on, we can pick an instance and tell us, if we use a collection, which instance we want for what situation. So it's kind of handy. So, but we need to do some transformations. So if we take a look at the transform geometry, we need to do some, as you can see, the points are at the center of the cube. So we need to do some basic math of like, well, we need to move the cube downwards by 1, by half the distance so that they're at the base of the leg. So what we're going to do is we're going to create a math node. We're going to use the multiply node. We're going to get the height and multiply by half, which is 0.5. It's a very simple little node. And then from there, I'm going to use another combine node. Combine x, y, z, separate. And I'm going to inverse this. So for example, I need it to move in negative z. So to make something inverse, you just hit -1, multiply by -1. And then put it into the Z axis. And then I'm going to plug this into the scale. Whoops, sorry, translation. So now, what I did is I basically multiplied it by half. So half the distance of the height of the legs is now moved down by half. So if I change the height of the table, the legs are always going to be the same height of that particular table. So I could have a 2 meter tall table, even if it's negative. Yes, a negative table. It's a hanging shelf now. So now I could have a 2 meter table, or a 1.1 meter table, or a kiddie table of 0.5 centimeters, and have a really nice time with this dynamic table shape. So that's cool. That's great. That's the beginning of what we want. And if we take a look at the size of the grid, we can see that it is now as wide as as long as we want it, and as wide as we want it or need it as well. And with the grid, we can add as many legs as we want. So we can have a center leg, or we could have 3 at one end, or we could have 3 on the side, or 4, or 4 and 3.
Why did you use a grid? Sorry.
Say that again?
Why did you use a grid instead of a plane?
So that I could add more legs.
Mm.
And also, geometry nodes doesn't actually have a plane option. So a grid gives you more flexibility. A plane only has 4 points and no more. But you can use a plane anyway by just setting it to 2x and 2y, and now it's a normal plane. So that's the power. So now we got that sorted. Let's do some quick labeling. And we'll just make this a light color gray so we know that this is all controlled. We'll put like this into a group. So in Bforartists, you have the side panel for these common operators that you would use. For example, right click, make a group, or join into a new frame, Control J. In this case, you can just click the button if you need it. The wireframe on, yeah, it's turned on. All right, let's go. Les recommends I turn on the wireframe so you can see on the grid here. I have 3 on the side, 3 on this end, which means it adds more lines. And when it adds more lines, it adds more points. So now I have 6 vertices instead of 4. So 2 times 3 is 6, 2 times 4 is 8. And as you can see, the numbers are increasing every time I add some legs. So that's the next thing. So after that, we're going to use the extrude mesh onto the actual table. So as you can see, this is where things get interesting and procedural. So we have the point where we've added the legs, which is all here. We've added the leg points. We've added the size of the legs whenever we need it. We've transformed it so that they're at the correct height. We've instanced the legs on the points of the grid, which is the table. And now we have extruded right after, and we've joined them together right at the end. So we got the points on the instances on the points, and now we're joining it together. So what I'm going to do is I'm going to extrude the table mesh, and I'm going to scale the elements to make the table a little bit bigger, like this. So now we have an extrusion on the table with, let's just keep it all together as one piece. And we have this table size here. And what we can do is we can extrude it. We can select the top side, and we can do another extrusion. And select the top selection. So as you can see, these pink boxes here are a Boolean. And since this is a field, it says, okay, there are 2 faces in the collection of this field. So this diamond shape says it is an array of data, meaning there's more than one. So there's more than one face for it to choose from. And this creates this dotted line that we can take a look, and it passes this dotted line, which means there's multiple attributes, all with the same value, which means 1 Boolean. So the 2 faces of this array is true, the top side, and this will be the selection. So if the selection is true, then extrude. So I extrude twice, and I can scale. And I can, in this case, I can scale the elements again, like this. And I can tell it to scale the side options. And in this case, I can use this to create kind of an inset on my table, like this. So if we take a look at our properties here, we can choose the width, the size, the length, and the height. And if we create another value here, so float to integer, just round it out, use this in my vertices, and now I can use a different control whenever I want to add more or less legs on the X and Y if I need it. So now I got many legs, or just 2 or 3 or 1. There you go. So here's an interesting looking table. So this is the basics of using procedural geometry to create something to help you do modeling in a programmed kind of way to help you save time in the future. So in this case, you could, for example, create a plant generator, which Plebes is very good at, and he's got some interesting products coming out soon. And he's also made a few. Or you could create some string things, which Shmuel has done before with like different types of woven string, woven ropes and things like that, which is another product that he has as well. Or you could create a cup generator, or a table generator, or you can create something for couches, or use it to create a rock generator. This has many things and many uses. But the basis is understanding when to use single values, understanding the execution. So that's one thing you need to keep in mind. It's an imagination generator. That's right, Liz. So one thing to keep in mind is these trees, this data, the fields on the domains, so the domains, the mesh, the curve, whatever, these are only evaluated and executed when the green line attaches to the group output. So this means generally the green line, to me, they call it a geometry line because that's where the data is stored. That's where you store the arrays of values and information that you need. But it's also the execution line. So nothing is evaluated unless it is attached to the green line. And anything like a value or a field, you can get data from that is stored inside the geometry, and you can set the data again as long as you have it connected and flowing through the execution lines, which is very similar to how construction blueprints work with Unreal Engine. Just need to check my Twitch. No one was chatting, that's okay. But thanks for watching. So I want to open up the microphone now to some basic questions, or if you have a piece of art that you'd like to submit, and if you'd like to showcase your art, now is a good time to write it into the chat, send it into the chat on Discord, and I will take a look at it here. I have about 15 minutes more or less because I need to return to work. No questions for now. That's okay. I did have another file where I was sharing the indice of something. Here's some side news. If you follow me on Twitter, I am studying with Plebes a little bit of geometry nodes every day. And with that, I share these studies and little examples onto Twitter. I'm also sharing them into help and tips here in the Discord server. And I've been creating these small examples, for example, studying each node. The latest nodes that I've been looking at are the first of the curve nodes, for example, curve to points. And I've also been taking a look at spline length, which is another node which is kind of useful. And with that, I'll be publishing these to Twitter every day during the week. Weekend, not so much. There we go. Here's the curve length node. So I'm trying to give them some colors to help you guys understand which node does what. I'm also trying to work on different types of viewers as I do it to give you guys some examples. But basically, over the next couple of months, I'll be publishing a couple of nodes every day. And you can follow along, and eventually I will share the files. If you're a beginner. But it seems like a lot of people that I know here have had quite a good amount of experience with geometry nodes. So it's a good thing that you're like that. Now it's just me playing catch up, really. Good work with that. So that's about it for today then. So once again, I'll be here next Friday for a longer session. And I will keep you guys posted on what's to come. The plans for, as mentioned, I did run a poll on Twitter concerning what to do with these Q&A and critiques. The 4 topics that we had in mind was thematic themes or thematic topics to talk about. For example, me telling last year and the year before, we were talking about layout, we were talking about storytelling, we were talking about habits and other techniques concerning the asset browser and other topics that we're familiar with that. We also had a look at rigging and animation basics and production management and planning and also script writing and editing, video editing with that. So this year we'll be taking a look at other topics, including geometry nodes and other interesting things to come. Another thing that was voted highly was interviews. So I'll be taking a look at different artists. If you'd like to be the star of the show, well, reach out, talk to me, and you'll get your 15 minutes of fame here. And we'll talk about your art, talk about your inspirations, your techniques, and a little bit about you. So don't be afraid to make some time on a Friday afternoon or evening, and we'll talk about your work. Or even if you have a product that you like to showcase or to talk about, also feel free to get in touch. And art review was the other option. So if you also have your art and you would not like to be the star of the show, but you would like some feedback on your art live, maybe with some examples or some talk, and then feel free to submit your art here in the Discord server or send it to me directly or ping me on Twitter as well. And with that, I will see you all same time, same place next week. And thank you. Oh, and before I go, Liz mentions that you don't necessarily need the value node. You could, if you want it to be dynamic per the modifier, you can use the group input node and create your own interface to drive those values. Thanks for clarifying that. I will have to talk about interfacing and planning your modularity of your nodes later. And yes, we're a little bit live still, but thanks everyone. And Darkfold, yeah, in the future we can go through animation basics in depth. So there we go. I'll bid you guys farewell.